Now begins Lecture 7, Chapter 6, A Process of Change, Metamorphism, and the Rock Cycle. This lecture is divided into three parts. First, we discuss metamorphic rocks, definition, and processes. Second, we discuss agents of metamorphism and metamorphic rock types. And third, we discuss metamorphism types in plate tectonic context and the rock cycle. On the left, you have a picture of a metamorphic rock called a gneiss that has interesting swirly bands of different minerals that have been recrystallized during metamorphism. First, we define what is a metamorphic rock. A metamorphic rock forms when a pre-existing rock, known as a protolith or a parent rock, undergoes a solid state change in response to modification of its environment. Solid state change means that the rock does not melt. One example is before metamorphism, a sedimentary rock called a shale may become a garnet schist after metamorphism. And this is the result of one or more metamorphic processes, which are listed as recrystallization, phase change, metamorphic reactions, pressure solution, and plastic deformation. In the case of the shale and the garnet on this slide, the rock certainly underwent some recrystallization and metamorphic reactions, and possibly other metamorphic processes. We'll discuss each of these processes in detail. Recrystallization involves the changing shape and size of certain mineral grains without changing the identity of the minerals. One example is that sandstone becomes quartzite during metamorphism. So the protolith is sandstone, has these tiny clasts, and they get recrystallized to quartzite grains that are closer together, actually forming on the edges of each of one another's boundaries. Phase changes are transformations into another mineral with the same chemical composition but a different crystal structure. So one example would be a transformation of graphite into diamond. Both minerals are composed of pure carbon but have different crystal lattices. And graphite, when it's subject to intense heat and pressure, may become a diamond. Metamorphic reactions are when atoms separate from pre-existing minerals and bond with other atoms to form new minerals. A great example of this is how clay and quartz, that are separate minerals in the protolith, in a sandstone or siltstone or mudstone, undergo metamorphism and alter to minerals of quartz, garnet, and micas. So this is the example that we saw in the first slide, changing from a shale to a garnet schist. Pressure solution is the result of dissolution occurring more rapidly where pressure is being applied. So one example is that spherical grains can dissolve and become elliptical grains during metamorphism when you've got convergence along in two opposing directions. So these grains are getting smushed like pancakes, and in between the layers of different grains where that smushing is greatest, the pressure is greatest, we have dissolution of the edges of the minerals and reprecipitation of new minerals as a result. Plastic deformation is a change in shape without breaking or dissolving. So if we took the same spherical grains and rather than having them dissolve under pressure on their edges perpendicular to the area of highest stress or pressure, these grains would just become elliptical at their boundaries. So they wouldn't dissolve, but they would become elliptical.